In this video, we will be learning about arithmetic series. This lesson is going to be learned through the Kuta software worksheet. Now, let's start. Evaluate the related series of each sequence. When we mean by evaluate, basically the instructions is saying that you must find the arithmetic series according to the quantity of n. How do we know the quantity of n? Well, you have to count how many terms or numbers are inside the specific sequence in a certain number. So for number 1, we can see that we have 6 numbers. So basically, what we're trying to find is S sub 6. And before we even start, I would like to say first that the formula for arithmetic series is given by S sub n is equal to n over 2 times the quantity 2a sub 1 plus d, which is the common difference, times the quantity n minus 1. In sigma notation, we use S sub n is equal to n over 2 times the quantity a sub n plus 1. This formula will be useful for sigma notation such as this test below. So we have the Greek symbol sigma. I'm not really sure what it actually meant in mathematics, but just to give you a brief elaboration, answering problems like these will require this kind of formula, the one that I'm highlighting in yellow, while I'll be highlighting in color blue the how do I say in in a sort of a language that the youth would understand, maybe the classic flavor of arithmetic series. So these kind of problems require this formula. So yes, let's move on to number 1. So for S sub 6, we know that a sub 1 is equal to 13, this one, and our common difference is you find it by subtracting a typical a sub 2 and an a sub 1. It could be a sub 4 or a sub 3. It depends on a typical greater term and a typical term that is lower than that. If you don't understand what I just said, basically, just think about that a sub 2 over minus a sub 1. Like 15 minus 13. So this one. This is a sub 2 and this is a sub 1. If you if you subtract 15 and 13, you get positive 2. And that will be your common difference. Oops, wrong color. Okay. And so far, I think that's all we need. So we enumerate S sub 6 is equal to 6 over 2 times the quantity 2 times a sub 1, which is 13, plus 2, which is our common difference, times the quantity n, which is 6, minus 1. And again, in this lesson, we will need our calculator. I suggest that you use a scientific calculator. It's way easier to compute, especially when during exams you usually don't have enough time. So, and if ever you have excess time in your exam, you could use it, you can make good use of it by rechecking your answers. So yes, with the calculator, the answer says S sub 6 is equal to 108. So that is correct according to the answer key. As always, you can download this Kuta software worksheet in the internet. this worksheet is really useful. I commend the author of this worksheet for giving a weight so that students will be able to learn. You know that the answer key can help a student um, learn. They would know if they get their outputs correct or wrong, and if they get it wrong, they'll find a solution. It depends. It still depends on the student. So yes. Number two, our a sub 1 is equal to 6, and our common difference. Subtract 11 and 6, we get 5. So in that case, how many numbers do we have in the sequence? 1, 2, 3, 4, 5, 6, and 7. So what we're trying to find is s sub 7. And obviously, we can now say that n is equal to 7. Alright, so s sub 7 is equal to 7 over 2 times the quantity 2, our a sub 1 is 6, 2 times 6 plus 5 times the quantity 7 minus 1. Alright, s sub 7, place the expression in the calculator. 7 over 2 times 2 times the quantity 2 times 6 plus 5 times 6. Our answer is 147. One question that's usually raised upon is, what's the difference between arithmetic series and sequences? Well, for arithmetic series, what we're trying to find is the total quantity of a specific number. But for arithmetic series, we are trying to find the summation of all quantities depending on the number or depending on n. So to apply it in the questions that we've just answered, for example, for number 2, we're trying to find s sub 7. We are trying to find the summation or the sum of these quantities without having to add them manually. So basically, the formula for arithmetic series is a shortcut so that we wouldn't have to add them all in a calculator. We all know that it's a hassle. And if you just use a formula, if we know how to use it, our mathematical computations would be way easier. So yes, let's move on to number 3. A sub 1 is equal to 22. Our d, our common difference, is equal to 6. Our n, 1, 2, 3, 4, 5. We have 5 numbers, so n is equal to 5. So what we're trying to find is s sub 5. S sub 5 is equal to 5 over 2 times the quantity 2 times 22 plus 6 times the quantity n, where n is 5 minus 1. Place it all in the calculator. Our answer would be 170. There. Let's move on. For number 4, we have 4 terms, so n is equal to 4. Our a sub 1, our first term, is 39. And our common difference is 10. Let's make an equation. So I'm sorry. S sub 4 is equal to 4 over 2 times the quantity 2 a sub 1, which is 39, 2 times 39, plus 10 times the quantity 4 minus 1. S sub 4 is equal to, place it all in the calculator, our answer would be 216. And with that, according to the answer key, these are correct. Let's move on. So, the instruction says, evaluate each arithmetic series described. So, let's just zoom in for number 5. My strategy for this, you can also follow with me. We have to find first a sub n and a sub 1. A sub n, by which is a sub 35 in this case, because the usual format of an arithmetic series sigma notation is that n, a sub n, the n of a sub n is the number at the top, and the number at the bottom, so this is a sub 1. This can never change. The number, the n here above can change. It could not be 35 all the time. So it could be any number. But a sub 1 will always be a sub 1. K will always be equal to 1 below the sigma notation, the sigma symbol. So yeah, let's move on. 5k, this is k, okay. K is equal to 35 for a sub n. So 5 times 35 minus 2, our answer will be like 5 times 35 minus 2, we get 173, which is equal to a sub 35. We'll encircle that. Just to let you know, whenever I encircle with my gray ink, with my gray pen, it doesn't mean that it's a final answer. The final answer is always boxed. So just to keep you from confusion. Okay, 5 times 1 minus 2, it's just basically 5 minus 2, which is 3. So 3 is equal to a sub 1. Now, let's continue. Again, let's use the formula that we've discussed a while ago. To recall, it is S sub n is equal to n over 2 times the quantity a sub n minus a sub 1. I'm sorry. This is plus a sub n plus a sub 1. Now, let's apply it. We know that our n is equal to 35. To keep you again from confusion, this is just k. It's a variable. It could also be n. So don't be confused with that. Our n is 35, is equal to 35 over 2 times the quantity. Our a sub n is a sub 35, which is 173, plus our a sub 1 is 3. So place that all in the calculator. Our answer, we would get s sub 35 is equal to 3080. So the sum of 35 terms, according to this sigma notation, is equal to, or is equivalent to, 3080. Let's move on to number 6. So the same process, we use this so that we could find, or we can derive from it, the a sub n and a sub 1. 3 times 35 minus 13, and for a sub 1, 3 times 1 minus 13. Now, 3 times 35 minus 13 is 92, while 3 minus 13 is negative 10. 92 is equal to a sub 35, which is a sub n, and our negative 10 is equal to a sub 1. Oops. There you go. Now, our n is equal to 35, the number at the top of the sigma symbol. S sub 35 is equal to n over 2 times the quantity is a sub 35 plus a sub 1, which is basically plus negative or minus negative minus 10. So S sub 35 then is equal to 1435. There you go. So also according to the answer key, 1435 is correct, and S sub 35 is 3080. Let's move on to number 7. The same process, this time it's a little easier, I think. 15 times 4, 4 times m, which is 15, and 4 times 1. So 15 times 4, 15, 30, 45, 60 is equal to a sub n, or a sub 15, while 4 is equal to a sub 1. Alright, so let's move to finding s sub 15. S sub 15 is equal to 15 over 2 times the quantity 60 plus 4. S sub 15 is then equal to, if you place it in the calculator, this expression, you get 480. Alright, so let's move on to number 8. 7 times m. This in a sub n, it's 10. So 7 times 10 minus 2. And for a sub 1, 7 times 1 minus 2. 7 times 10 minus 2 is 68. 68 is equal to a sub 10. And 7 minus 2 is 5. 5 is equal to a sub 1. Now, place these in a calculator. A sub 10 is equal to 10 over 2 times the quantity 68 plus 5. S sub 10 is equal to 365. Alright, let's move on to number 9. So 3 times 6 is equal to 18, which is equal to a sub 6. And 3 times 1 is equal to 3, which is equal to a sub 1. Now, what we're trying to find is S sub 6. So S sub 6, S sub 6 is equal to 6 over 2 times the quantity 18 plus 3. S sub 6 then is equal to 63. There you go. And let's move on to number 10. 3 times 45 minus 9 is equal to 126, which is equal to a sub 45. Now, for a sub 1, 3 times 1 minus 9 is negative 6, which is equal to a sub 1. Now, for S sub 45, what we're trying to find here is S sub 45. I almost forgot, we have to label our n. N is equal to 45 there. Here, n is equal to 6. And for the rest, here, n is equal to 15. And for number 8, n is equal to 10. Okay, let's move back to our problem. S sub 45 is equal to 45 over 2 times the quantity 126 plus a sub 1, which is basically 126 minus 6. And with that, S sub 45 is equal to 2,700. There you go. Now, but all of these are correct. 480, 365, 63, and 2,700. Let's move on to number 11. Now, this time, we're given, it's still a sigma notation by the looks of it. We have a sub 1, a sub n, and n. Basically, what we're trying to find now that we know that n is equal to 14, we're trying to find S sub 14. Now, S sub 14 is equal to 14 over 2 times the quantity 146 plus 42. If you'd ask that, how do I know that this problem is still relative to the formula of sigma notation? Why do we have to use why do we have to use S sub n is equal to n over 2 times a sub n plus 1? And we're not using n over 2 times the quantity to a sub 1 plus d times n minus 1. Why are we not using this one and instead this? Well, the answer for that is, we know that our given, we only have a sub 1, which is available in this formula. We have a sub n, which is also available, and our very own n. So we can use this formula. As for the other arithmetic series formula, we don't have our common difference. So I think that's what sets apart between these two formulas. One is for sigma notation, one is when you have the common difference. So yeah, that's all. Let's get back to our problem. Just make this eraser bigger. Okay. So S of 14 is equal to 14 over 2 times the quantity 146 plus 42. S of 14 is equal to 1316. There you go. For number 12, S sub 10, we know that n is equal to 10. So what we're trying to find is S sub 10. S sub 10 is equal to 10 over 2, n over 2, times the quantity 22 plus 4. When we place this expression in the calculator, our answer is 130. There you go. Now let's move on to the second page. For number 13, the problem stays as is. S sub 13 is equal to 13 over 2 times the quantity 122 plus 2. S sub 13 then is equal to, or is equivalent to 806. Alright, let's move on to number 14. S sub 13 is equal to 13 over 2 times the quantity negative 102 plus negative 18, or basically minus 18. So S sub 13 is equal to negative 780. Let's move on to number 15. What we're trying to find is S sub 16. S sub 16 is equal to, right, we have to enlist first what A sub 1 is, so that we won't be confused. A sub 1 is equal to 20, and is equal to 16, and yeah, I think that's all that we should know. Well, now I think there's a turning point. So we won't be using the sigma notation formula anymore, because we don't know what A sub n is, because we know that this is random, so we don't know what A sub 16 supposedly is. We only know until what A sub 4 is. So in this case, we'll be using the formula, the n over 2 times the quantity 2A sub 1 plus d times n minus 1. The quantity n minus 1. Because we may not see what our common difference is right now, but we can already derive from it what the common difference is. So 27 minus 20, our answer is 7. 34 minus 27, our answer is 7. 41 minus 34, the answer is still 7. So our common difference is 7. Now, for S sub 16, we get 16 over 2 times the quantity 2 times our A sub 1, which is 20, plus our 7 times the quantity n minus 1, which is 16 minus 1. S sub 16 then is equal to, is equivalent to 1160. You might also ask that why don't we compute for A sub 16? I think that solution is unnecessary, since we don't really need what A sub 16 is. What we're trying to find is S sub 16, the summation of 16 numbers according to this sequence. So yeah, let's make sure. Let's use the calculator. 16 over 2 times the quantity 2 times 20, which is basically 40, plus 7 times 15. Yes, our answer is still 1160. If I think I can show you another way of solving this, but I doubt that you would take this long cut. But either way, I'll still teach you how. So if you really still want to use, if you're really in love with the formula, n over 2 times the quantity a sub n plus a sub 1, this is another solution. So for s sub 16 is equal to 4. Well, we won't be finding s sub 16 first. We have to find a sub 16. A sub 16, use the arithmetic sequence formula. A sub 1 is 20 plus 7 times the quantity 16 minus 1. And if we place this in the calculator, 20 plus 7 times the quantity 16 minus 1, a sub 16 is equal to 125. Now, we know what a sub 16 is. We could use the formula. So 16 over 2, n over 2 times the quantity a sub n, which is 125 plus 16. If we place this in the calculator, I'm so sorry. This is not 16, this is 20. A sub 1 is 20. So S sub 16 is equal to 1160. There you go. So as you can see, the answers are the same. Let's move on to number 16. I just showed you 2 solutions, but it's up to you on how you'll be solving it. But I prefer you choose the shortcut. I prefer that you choose what's easier for you, the easier technique, what you find easier, what you find more efficient when you're taking an exam. So yeah, n is equal to 15, a sub 1 is equal to 20, and our common difference is equal to 10. Now, our n is 15, so what we're trying to find is s sub 15. S sub 15 is equal to 15 over 2, n over 2, times the quantity 2 a sub 1, 2 times 20, plus 10 times the quantity n minus 1. So, given that we have this formula, we place this in the calculator, our answer would be 1350. Alright, let's move on to number 17. Okay. As n is equal to 10, a sub 1 is equal to 7, and d, our common difference, is equal to 2. Let's solve for s sub 10. S sub 10 is equal to 10 over 2 times the quantity 2 times a sub 1, which is 7, plus 2, which is d, times the quantity n minus 1. So s sub 10 is equal to 160. Let's move on to number 18. N is equal to 11, a sub 1 is equal to 10, and our common difference is equal to 2. Now, we'll find s sub 11. S sub 11 is equal to 11 over 2 times the quantity 2 times a sub 1, which is 10, plus 2, which is d, times the quantity 11 minus 2. S sub 11 then is equal to 220. There you go. Let's move on. Determine the number of terms n in each arithmetic series. Now, basically, we'll still use the formula that we've used here. We'll use this formula. Let's move on. Let's move to number 19. We'll still use the formula. So let's just enumerate again. S sub n is equal to n over 2 times the quantity 2 a sub 1 plus d times the quantity n minus 1. So S sub n, we don't know what our n is. So n is equal to question mark. So in order to find n, we'll be using the formula to substitute values. So although we don't know what n is, we know what our a sub 1 is, what our a sub n is, the given, and what our s sub n is. So basically, we know what our s sub n is, so we'll place 690 there, and 2 times a sub 1, 2 times 19, plus, we don't know what our common difference is. I'm so sorry. I don't think we'll be using the long formula. We won't be using this one. We'll be using the shorter one. The one that no longer needs the common difference. I'm sorry for the mistake. I'll repeat. So n over 2 times the quantity a sub n plus a sub 1. So there. N over 2, our a sub n is 96 plus our a sub 1, 19. So we multiply both sides by 2 in order to eliminate our denominator. So 690 times 2 is 1380, which is equal to 96 plus 19 times n. Let's move here. 96 plus 19 our answer is 115. The 1380 divided by 115 is 12. Our n is equal to 12. Alright, let's move to number 20. So we won't be taking this slow anymore. 4475 is equal to n over 2 times the quantity 163 plus 16. Multiply both sides by 2. 4475 times 2 is 8950. And 163 plus 16 is 179. So 8950 divided by 179 is 50. So our n is equal to 50. There. In the answer key, below, these are correct. And as well as these. Alright, let's move to number 21. Now we have 822 as our s sub n, which is equal to n over 2 times the quantity 118 plus 19. We multiply both sides by 2. 822 times 2 is 1644. Now, 118 plus 19 is 137. Multiply it by n, we get 137n. 1644 divided by 137 is 12. Therefore, our n is equal to 12. Let's move to number 22. 423 is equal to n over 2 times the quantity 79 plus 15. We multiply both sides by 2. 423 times 2 is 846. And 79 plus 15 is 94. Multiplied by n, we get 94n. Now, divide both sides by 94. N is equal to 9. Let's move to number 23. Now, 21 is equal to n over 2 times the quantity... Oh wait, hang on. This time we have our d, but we do not know what our a sub n is. In this case, I think we are going to use the longer formula this time. So, s sub n is equal to n over 2 times the quantity 2a sub 1 plus d times the quantity n minus 1. So, a sub n is equal to n over 2 times the quantity 2 times a sub 1, which is negative 3, plus 2, which is d, times n minus 1. S sub n is equal to n over 2 times the quantity negative 6 plus 2n minus 2, distributive property. And we could simplify this further. Negative 6 would be negative 8. There you go. We know what S sub n is. I should have substituted this earlier. It's 21. Multiply both sides by 2. We get 42 is equal to n times negative 8 plus 2n. So, 42 is equal to 2n raised to 2 minus 8n. We moved 42 to the other side. 2n raised to 2 minus 8n minus 42 is equal to 0. And in this case, we'll be applying our lesson of quadratics to, we're going to factor this expression. So 2n is equal to 0, something like that. And since the teacher allows us to use the calculator during the exam, we could use, I'm still not used to my new scientific calculator, but basically we use matrix in our mode setup or menu setup. I might make a video about that on how to solve. I won't be using my new calculator right now. Let's do factoring the old-fashioned way. 42. So 42, we have 7 times 6, maybe 36, 42. Or we can use maybe let's try that first. So if we put negative there and we put a plus sign there, 6, negative 6 times 2 is 12. I don't think it would fit. 42 divided by 2, 21 times 1. 21 times 2. I don't think so. 4. Nope. 12, 24, 36, 48. Maybe if we put negative 7 here and positive 6 there, negative 14 plus 6, we get 8, negative 8, which is exactly this number. So yes, we found the factor. Let's move on. 2n is equal to negative 6 and n is equal to 7. In this regard, we should always remember that we'll cancel out the quantities with the negative symbol, and the final answer would then be our quantity without a negative. So this is positive, and this answer is correct. Let's move to number 24. It's quite a long solution, but if you get used to it, it's going to be a piece of cake someday. 228 is equal to n over 2 times the quantity 2 times 4 plus 7 times the quantity n minus 1. Multiply both sides by 2. 228 times 2 is 456. And the other side, we have n times the quantity 8 plus 7n minus 7. 456 is equal to, let's simplify this further. We have 1 plus 7n. So 7n raised to 2, or 7n squared plus n. We move this part. 7n raised to 2 plus n minus 456 is equal to 0. 7n, we factor the expression. Our answer would be, well, this is a big number, so we'll just use the calculator, and turns out our answer would be s is equal to 8. And the other will be negative 57 over 7, in which this is wrong. We won't be adding that in our final answer. This instead would be our final answer. Okay, let's go to number 25. This time, let's find what our our a sub 1 is. A sub 1 is negative 2. And our common difference is negative 10. Now, we'll still be using the old-fashioned formula. S sub n is equal to n over 2 times the quantity 2a sub 1 plus d times the quantity n minus 1. Now, let's go to... we don't know what n is, by the way. That's one observation. But we do know what s sub n is, which is 224. So negative 224 is equal to n over 2 times the quantity 2 times a sub 1, which is negative 2, plus, minus 10, times the quantity n minus 1. Now, multiply both sides by 2. Negative 224 times 2. Our answer is negative 448. And in the right side, we disregard the we disregard the positive 2. So n times the quantity negative 4 minus 10n plus 10. Negative times a negative is positive. So yeah, we follow the integer rule. Let's simplify this further. Negative 4, positive 10, positive 6. There you go. Okay, so let's further compute. Negative 10n raised to 2. N times n is n raised to 2. Plus 6n. And we move 448 to the other side. It feels better to find our first term, which is the one usually with squared. So move negative 10 n raised to 2 to the other side, make it positive, and minus 6n. And you don't have to move 448 anymore. So in this scenario, we are the best solution right now is to use the calculator again to factor this expression, because it's super big. Only a big brain genius could solve this. Even I couldn't. So x is equal to 7, and the other one, x sub 2 is negative 32 over 5. We know that our negative quantities, disregard them, and this will be our final answer. Oops. I'll just arrange. There you go. So this is our final answer, which is correct. Let's move to number 26. A sub 1 is equal to negative 16. D, our common difference, is negative 10. So yeah, let's continue. S of n is equal to n over 2 times the quantity 2 times a sub 1 plus d times the quantity n minus 1. Multiply both sides by 2. 1818 times 2 is 3636. Don't forget the negative sign. Times the quantity, times n. Our quantity, let's simplify. We have negative 10n. 16 times 2 is 32. Put a negative sign. Negative 32 plus 10. It's basically 10 minus 32. We get 22. Negative 22. So in that regard, 3636, negative 3636 is equal to negative 10n raised to 2 minus 22n. So let's further solve. Move the 10n raised to 2 to the other side to make it positive. There you go. There you go. And we use the scientific calculator to factor this expression. Our n is equal to 18. And if you want to know the other n, it's equal to negative 101 over 5, which is negative, so disregard. this is correct. So yeah, I think this is everything that we have to know in the Kuta software worksheet. These are correct. So yeah, I'll just scroll slowly so that you can see my solutions. Everything that we did in this video. There you go. So yeah, the answer keys are below, just in case you're not sure, if you don't really trust my answer key. So you could just check, and turns out these are still the answers that you're looking for, the answers of the corresponding problems. So yeah, I think that's everything in this video. Let's not make the video longer. So yeah, goodbye and thank you.